In 2023, an ex-NASA engineer claimed he built a machine that can lift itself against gravity without using any fuel. No rockets, no fire, no exhaust, just electricity. If true, it would break the most sacred laws in physics and rewrite everything we know about space travel. So, is this just another hoax or a door to the future? The engineer's name is Charles Bueller. He used to work for NASA, making sure rockets don't blow up randomly. He was a part of the Space Shuttle, Hubble, ISS, and other huge projects. Now, Bueller and his team work at a private company called Exodus Propulsion Technologies, trying to build a long-term dream of space engineers, a spacecraft that doesn't need fuel. It's the kind of thing that would instantly change everything about space travel. Just think of the future where you could go to the moon, Mars, or wherever you'd like without spending tons of resources. And he claims that he and his team have finally cracked the code. That they've built a machine that can lift itself in the air without any propellant. You got it right. The team claims to have violated Newton's third law, the basic rule of our world that every action needs an equal and opposite reaction. For example, in rockets, you throw fuel out the back, that's action. Being pushed by it, the rocket goes forward. That's the reaction. A magical device like that would also violate the conservation of momentum. When you push on something, you gain momentum, but something else has to gain equal momentum in the opposite direction to balance the books. But this device would change the total momentum of the system out of nowhere. If you're getting motion without pushing against anything, how in the world did you do that? It's like a balloon that can somehow move forward without blowing out any air. If the machine actually works, there must be some new, unknown force of nature that we've somehow missed in hundreds of years of physics. Bueller himself called it the new force. Let's try to figure it out. To create this magical device, they used electrostatics. Their test device was little, a 30-gram object about the size of a card deck, and it managed to create thrust or push using electric fields, a kind of invisible force made by electric charges. The new force starts working when two things happen in the system. The first one is electric imbalance. There's some electric pressure happening across parts of the device, kind of like air pressure. If it's not spread out evenly across it, for example, one side has more electric push than the other, that's the first ingredient. And that happens when the electric field, the invisible force that electric charges create, is set up just right. It has to spread out in a certain way. Not in straight lines, but uneven and fanning out, like sun rays or the spokes of a wheel. And boom, when it happens, the device pushes on itself and makes the whole object move. At first, the mysterious new force was tiny, barely noticeable, little to no thrust and noise. But with each upgrade, things started to shift. And in 2023, they finally measured enough thrust to overcome Earth's gravity. The weirdest part is that, according to Bueller, in some cases, the thrust keeps going even when the power is off, as long as there's still charge left in the materials. That's weird. That's really weird. That hints at something totally new in physics, something deeper than we currently understand. So now, any honest scientist starts sweating, because that sounds bananas, and frankly, it might be. Bueller admits this is still early work. The team published their discovery and got a patent. By the way, the company includes people who've worked at NASA, Blue Origin, and the US Air Force. They've been tinkering with this stuff for decades. Charles presented his findings at APEC, a conference for people who are passionate about alternative propulsion and crazy stuff like warp drives, anti-gravity, and ways to make Star Trek real. Now, they're actively working on that project. Of course, this stuff got very controversial, and lots of scientists are skeptical. There might be a mistake no one has caught yet, so they want to test the machine in space. If it works out there too, it could change space travel forever. It might be real, because it's not the first time we've discovered something like this. Recently, a startup called Evo Limited claimed that they'd built a quantum drive, another propulsion device that apparently didn't need fuel. They said they're tapping into a weird controversial theory of physics called quantized inertia. It was cooked up by a British physicist named Mike McCulloch. He basically said that inertia, the thing that makes objects resist acceleration, isn't a basic rule of nature, but an effect caused by some weird quantum radiation at the edge of the observable universe. In simple words, if QI is right, then under the right conditions, you might be able to generate thrust without throwing anything backward. You don't need fuel, just electricity and a clever enough setup. Many scientists don't buy into it, but who knows? Maybe that's why these new inventions could actually work. Anyway, initially, the IVO company was founded by a small team of tech guys who wanted to find wireless power. Their first big idea was called CBAT, capacitive-based aerial transmission. Basically, a fancy way to wirelessly send electricity through the air. But somewhere along the way, they pivoted. They started wondering, if we can move electricity through the air like this, can we move objects too? Can we rethink inertia itself? So, in 2021, they began working on a propulsion device based on this quantized inertia theory. They built the quantum drive around this idea. It was a self-contained electric system. No fuel tanks, no combustion, just a plug-and-play box that makes spacecraft move. They said it's light, stackable, and can be bolted onto a satellite like a toaster. And it weighs just a few hundred grams, way lighter than traditional thrusters. In 2023, they tested it, not in someone's garage, but in a legit vacuum chamber, simulating space conditions. The team said they ruled out every known force that might explain the results, and that it did generate thrust, not a lot, but consistent and measurable. Then came the big moment. IVO and a partner company, Rogue Space Systems, launched the quantum drive into space, and now they're waiting for the results of the tests. A lot of physicists think it's all nonsense. Some of them notice that this stuff is impossible because they'd be perpetual motion machines. Basically, if a device like this actually worked, you could use it to make infinite energy, which violates the first law of thermodynamics. But IVO says they're not doing that. They say QI works within our normal Newton's laws, just a bit differently. Anyway, all this stuff needs double-checking. Skepticism is so right because a lot of people get some unpleasant flashbacks. In 2001, a British engineer named Roger Scheuer introduced the M drive. It was this weird cone-shaped device that supposedly created thrust without pushing anything out the back. People were super excited. NASA even tested it with their EagleWorks team, and in 2016, they said they've detected tiny amounts of thrust from the M drive. The media absolutely blew up. People and scientists were hyped up, but later, bigger studies, including one from a German university that really went deep, found the sad result. It was just an experimental error. By 2021, the verdict was in. The M drive didn't work. It was all experimental noise, misunderstood data. Another dream went down the drain. Many propellantless designs have crashed into one huge, stubborn wall, the laws of physics. So it's too early to say that these startups just change the world forever, but if it turns out to be real, it's not just a new engine, it's a new era. NASA sent a spacecraft right into the sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. And it doesn't make any sense because it's farther away from the sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast, when it happens, the influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the sun went off the page, literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the Moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was cancelled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the Moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the Moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then it will descend to one of the largest basins on the Moon and spend 1 lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket.
Another rocket blasts off from the launch pad and heads for the International Space Station. To deliver the payload there, you'd have to pay about $18,000 per 1 pound of its weight. Imagine spending that much money on just 3 bananas. So the weight of the rocket and spaceship itself is calculated literally down to every bolt and every ounce. But engineers normally use about 600 pounds of white paint to coat the rocket. That's $10,800,000. Let's see. You could buy a 3-masted schooner, a gold-plated Bugatti Veyron, or a penthouse in Manhattan, maybe 2 of them, for this money. Or perhaps even a private island. Well, a small one. But engineers have to paint rockets white so that they don't turn into flying ovens. Imagine sitting in a black car in a parking lot at noon in the summer. The air conditioning is off. You'll start feeling uncomfortable in a couple of minutes. But if your car is white, it will heat up more slowly. It's all about the reflectivity of the material. When the sun's rays touch a black surface, they get absorbed. As a result, everything under this surface heats up. But when the rays reach a white surface, they get reflected. This surface absorbs much less heat. That's why you feel much hotter wearing a black t-shirt in the summer than while putting on a white one. You also look hotter. But I digress. Spaceships fly in space, and the temperature there is about minus 455 degrees Fahrenheit. But space is also a vacuum. That means there's no air particles that can transfer heat up there. So nothing blocks the sun's rays and prevents them from heating up the surface of the rocket to insane temperatures. If the rocket was black, it would absorb all those rays, and astronauts would feel like a chicken in an oven. Besides heat, the sun emits radiation. Earth's magnetic field and atmosphere protect us from its destructive effect. But there's no such shield in space. So the white paint on the surface of spacecraft also protects astronauts from radiation. Spacesuits are white for the same reason. So is the International Space Station itself. On Earth, most airplanes are painted white. But even with white paint on the paneling, a spacecraft can heat up too much, and its other side, where the sun's rays don't reach, will cool down a lot. After all, space is very cold. So, engineers came up with a clever way to transfer the heat from the sunny side of the spaceship to its dark side. There are tubes under the paneling. They're filled with ammonia. The ammonia evaporates after absorbing the heat from the surface. Then it transports this heat to the colder side of the spaceship. There it gives off the heat and returns to its liquid form. After that, the ammonia moves back to the illuminated side of the spacecraft. The second reason why we paint spacecraft white is that space is black. And if you paint your spaceship black or any other color, you won't be able to see it. This will make it difficult to dock spaceships with each other or with the ISS. But a white spaceship is perfectly visible against the black background of space. The third reason is that you can see even the slightest damage on the spaceship if it's painted white. Long before launch, the spaceship is assembled in a hangar from dozens of different parts. Then it's delivered to the launch pad. And if something went wrong in that process, you will see any scratch or crack on the white surface. Or if any part is leaking, you'll quickly notice a stain on the white surface. But it's not just the surface of spaceships and the ISS that gets painted white. The interior is white too. If you look at photos of astronauts on the International Space Station, you'll see that most of the interior is either white or beige. Again, it's all about the reflectivity of this color. Electrical power is an important resource on the ISS. Every light bulb and LED must be used economically, and white surfaces effectively reflect the light from the bulbs all over the station. This way, it isn't dark there even without a lot of lighting devices. And this is the Saturn V, America's moon rocket from the 70s. It's the biggest, most powerful, and heaviest payload-carrying rocket ever made. And it's not completely white. Even more interestingly, its white parts are painted this way to provide protection from the scorching Florida sun on the launch pad. But you can also see black stripes all over the rocket's body. Thanks to them, cameras on the ground can determine its rotation speed. The point is that at launch, a rocket spins exactly like an arrow fired from a bow. This helps it to be more stable during the flight. When the rocket is launched and starts spinning, all video cameras are pointed at it. When experts watch the video of the launch, they analyze every frame. They pay attention to how the black stripes move. This way, they can calculate the rotation speed of the rocket. Now, let's take a look at the space shuttle. You can always recognize it by the huge orange tank attached to the spacecraft. It contained liquid oxygen and hydrogen to propel the space shuttle into orbit, and it was orange because it's covered with insulating foam. Oxygen and hydrogen can only be in a liquid state at extremely low temperatures and under high pressure. So engineers tried to protect the fuel from overheating with this insulation. But originally, this tank was white too. The reason was the same, to reflect the sun's rays. But later, engineers decided that the foam insulation would be enough and the paint layer was removed. So they managed to save about 600 pounds of weight and deliver more payload into space. And 600 pounds is almost 72 gallons of water or 900 large burgers. Wow, how did that get on board? Interestingly, the space shuttle itself wasn't completely white. It had a black bottom. That's to withstand the extreme heat of re-entering Earth's atmosphere. When the space shuttle completed its mission in space, it started to descend. At the height of, let's say, about 400,000 feet, it traveled at 25 times the speed of sound. When the space shuttle re-entered the atmosphere, it literally collided with air particles and began to break. At this point, its bottom heated up due to friction with the air. Try rubbing your palms together, they become warmer. The same happened to the bottom of the space shuttle, only it heats up to 2300 degrees Fahrenheit. By comparison, the temperature of a hot frying pan is about 6 times lower. Just touch it and see. Nah, don't. That's why engineers had to protect the bottom of the space shuttle from overheating with special black tiles. They're called HRSI, which stands for High Temperature Reusable Surface Insulation. Catchy. They're made of porous silicon, which means they're very light but can withstand extreme temperatures. But when it comes to new rockets, we won't have to worry about painting them white or protecting them with tiles. We'll build new rockets and spacecraft with stainless steel because it's easier, cheaper, and faster. Take the SpaceX Starship. This thing will be able to take people to the moon, and in the future, even to Mars. And it's made of stainless steel. 2 pounds of carbon fiber, which is used in conventional spacecraft, cost about $200. But the same amount of stainless steel costs about $3. And since the weight of the spacecraft and booster is about 300 tons, the difference is huge. Stainless steel does a good job of reflecting the sun's rays, too. Even though it's dark, it's shiny, so the ship won't overheat. In addition, stainless steel is great at withstanding low temperatures, so it won't deform in cold space. And to save Starship from overheating on re-entry, its paneling is designed like a sandwich. There's an outer layer of steel, then a layer of air, and an inner layer of steel. Kinda like an Oreo. The air acts as thermal insulation. So, Starship with people on board is attached to the booster on the launch pad. Ignition. The booster helps Starship escape Earth's gravity, then it undocks. At that point, Starship fires its engines and enters orbit. By this time, it has used up almost all its fuel. Meanwhile, the booster re-enters the atmosphere and makes a soft landing. It docks with a refueling ship. Ignition. The booster launches again, takes the spacecraft into orbit, and returns to Earth. The refueling ship docks with the Starship and replenishes its fuel supply. It also transfers cargo to Starship. Then it undocks and returns to Earth for its next mission. At the same time, Starship turns on its space travel engines and heads for its destination. The journey to Mars will take about 7 months. SpaceX also plans to use Starship for traveling on Earth. Launches can take place from water platforms near big cities. Then, the trip to the other side of our planet will take no more than 1 hour.
Let's say a spacecraft runs out of power far in deep space. It wouldn't fall in the traditional sense because there's no gravity. Newton once said that an object remains in motion unless acted upon by an external force. In our case, this external force is gravity. In other words, if there's nothing with gravity around, it would continue to move due to inertia. It would keep going the way it did, without us being able to change its trajectory or adjust it in any way. It would keep traveling through deep space, almost forever. Well, at least until radiation and cosmic rays destroy it. And unless some celestial body like an asteroid doesn't destroy it either. And of course, unless it encounters something with a gravitational pull, like a planet or a star. The likelihood of all this depends on the location and trajectory of the spacecraft. Voyager 1 was launched by NASA in 1977. It's been on its journey for almost 50 years now. Right now, it's the farthest human-made object from Earth, more than 50 billion miles away. It's already very far from all our planets, and it's the first spacecraft to enter interstellar space, the vast, empty space that exists between stars in a galaxy. It's the space outside our solar system, where there are no planets, moons, or other objects associated with our Sun. However, it's still in our solar system. To leave it, Voyager 1 needs to bypass the Oort cloud, a big, icy collection of objects where all the comets in our solar system probably come from. It will take Voyager about 300 years to reach the inner edge of the cloud, and then about 30,000 years to bypass it. Voyager 1 has a special plate on board, like a message in a bottle. This plate is called the Golden Record. It's not really golden, it's actually a shiny gold color. On this plate, there are things that tell a story about Earth. It was created in case Voyager ever encounters any extraterrestrial beings. The record has greetings in different languages, music from Earth, and even the sounds of nature, like birds chirping and the wind blowing. As the distance between us increases, the signal strength from Voyager 1 weakens over time. Eventually, it may become too weak to be detected by our communication equipment. The power output of Voyager 1's engine also declines over time. It's slowly running out of fuel. When all its systems shut down, we will lose contact with the spacecraft. Voyager 1 will work until 2025. After that, it will continue its journey on inertia. Luckily, it was designed to last, and the chance that it will encounter anything on its way is very small. Considering this, it might even keep going for billions of years. One day, it might even reach other star systems, and maybe even outlast our Sun. The same goes for Voyager 2. It will keep traveling until it reaches interstellar space, joining its twin brother. Voyager 2 will continue to send us scientific and systematic data for a while, even in interstellar space. However, it will also cease to function eventually, becoming a silent artifact drifting through the Milky Way. When there's something with gravity near the spacecraft, the inevitable happens. It falls onto that object. This is why out of the vast South Pacific Ocean beyond New Zealand lies a unique and intriguing place known as the Spacecraft Cemetery. Officially, it's called the South Pacific Ocean Uninhabited Area. It's located near Point Nemo, the most remote spot from any island. It serves as the final resting place for spacecraft that have completed their missions and reached their lifetime limit due to wear and tear. Sometimes, these larger spacecraft are too hefty to burn up during re-entry into Earth's atmosphere. In that case, they're directed to crash or splash down in this remote ocean location. This helps protect us from any potential harm during re-entry and impact. There are, however, some big problems with this place. Scientists are worried about the impact this spacecraft cemetery has on the ocean. When spaceships come back to Earth, they often spill chemicals. One of these chemicals is hydrazine, a dangerous rocket substance. Unfortunately, it might not completely burn up during re-entry, so it leaks out into the ocean, posing a threat not only to marine life, but to us as well. We made up some rules, both within countries and internationally, to stop this. However, it's not easy to figure out how risky it is for certain spacecraft to enter the cemetery. We can't say for sure how much of a substance is left after it enters the air. As for spacecraft that don't fall, they're often left in space as debris. This is what we call any man-made object orbiting Earth that's no longer useful. It's also very dangerous. There are over 27,000 pieces of space debris orbiting Earth at high speeds. All this puts human and robot missions at risk and harms spacecraft. As we mentioned, usually we get rid of space debris by trying to bring the crafts back to Earth. This makes them burn up when they re-enter due to high speeds and air pressure. This usually works with smaller objects. There are also riskier methods, like letting spacecraft break down themselves, or crash into other things, or blow up. These methods aren't great because they just make up even more debris, even if it's smaller. So now, scientists are trying to find new ways to get rid of retired spacecraft. For example, nets and magnetic arms. There's also a thing called reusable spacecraft. It's a space vehicle that's built to be used more than once. For example, space planes such as the Space Shuttle and the Dream Chaser, or capsules like the SpaceX Dragon. They're designed to launch, orbit, come back to Earth, and do it all over again. But it's important to make sure these spacecraft and their passengers or cargo stay safe during the return, which is quite hard to do. Reusable spacecraft have special systems to guide them back to Earth safely. The Space Shuttle, for example, had OMS pods, sort of special backpacks that help the spacecraft move and control its position in space. The SpaceX Dragon had its own engines to slow down and enter the atmosphere in a controlled way. They also have a heat shield to protect it during re-entry. The heat shield can be made of different materials, but they need to be tough and able to withstand multiple trips. Coming up with a heat shield that's both strong and lightweight is a bit of a challenge. Finally, if a spacecraft lands on a runway, it needs wings and landing gear. They also add weight. Some designs like lifting bodies or the delta wing of the Space Shuttle try to reduce the mass of these parts. After landing, the spacecraft might need some fixing up before it can go on its next adventure. This process can take a while, up to a year, and it might not always be possible to use the spacecraft again if it's been fixed up. There's also a limit to how many times a spacecraft can be fixed and used again before it has to retire. Different spacecraft have different abilities to be reused. Finally, sometimes we can rescue a spacecraft or even remake and repurpose it. Voyager 2 is one of the examples. It had a little trouble with its radio in 1978. Engineers fixed it by using a backup system. Since then, it's been exploring our solar system for over 40 years. The Hubble Space Telescope is the most famous telescope we have, the grandfather of them all. However, it had a blurry start in 1990. The work wasn't done at all as expected. The pictures were of low resolution. Luckily, astronauts fixed it right in space in 1993. To do that, they used some corrective mirrors. Now it gives us fantastic views of the universe. As you can see, even in bad scenarios, there are many possible options to solve spacecraft-related problems.
Imagine flying in a spacecraft in a cloud of asteroids at high speed. You dodge one more, and then hit the gas pedal to the floor and crash into an asteroid at full speed on purpose. This is exactly what NASA is going to do in the near future. The entire mission will begin at Vandenberg Air Force Base in California on November 24th. Let's follow it step by step. So, the Falcon 9 booster rocket is already on the launch pad. It's as tall as a 22-story building, or 11 giraffes, and it can get about 8 tons of cargo into orbit. So you could send a big elephant into space, and a supply of food for it. Countdown, 3, 2, 1, ignition! Smoke clouds everywhere, and the rocket begins to gain altitude. 9 engines are working at full power to accelerate the rocket. At its peak, it reaches speeds 10 times faster than the speed of sound. And then, the rocket engines shut down, and the rocket's first stage undocks to return to Earth. A couple of seconds later, the second stage receives the ignition command. It turns on its one engine and climbs even higher to orbit. The cargo capsule then opens and releases the DART spacecraft. DART stands for Double Asteroid Redirection Test. Once released, the spaceship deploys 2 large solar panels. It'll convert solar energy into electrical energy to power a revolutionary ion engine. Conventional engines create thrust by burning tons of fuel and ejecting it outward. The rocket itself is essentially pushing off the emitted gases. The ion engine will not burn fuel. It'll use a strong electric field to accelerate the ionized gas. Like conventional rockets, it'll eject this gas and create thrust by repelling it. And though the ion engine produces less thrust, it can accelerate the spacecraft to higher speeds. So regular rocket engines have an excellent performance on the road. They push the pedal to the metal, burning a bunch of fuel, while the ion engine slowly accelerates. But when a conventional rocket needs to make a refueling stop, the ion spacecraft will whiz past the regular one at insane speeds. So the DART spacecraft begins its year-long journey. By comparison, a flight to Mars would take about 7 months. Fast forward 1 year ahead, and we've arrived. This is the asteroid Didymos. The far point of its orbit is 2 astronomical units from our star. That's 2 Earth-Sun distances. At this point, the Sun begins to pull the asteroid back, and then it approaches the closest point to the star, 1 Earth-Sun distance. That is, its orbit lies very close to the orbit of our planet. Didymos made its closest approach to Earth at a distance of about 4.8 million miles. That's 20 times farther than the Moon's orbit. It takes 770 days to complete one such revolution around the Sun. So, Didymos is not considered a hazardous asteroid, but in the future, it'll approach the Earth even closer, and the consequences of a collision with it could be catastrophic, given its size. It's bigger than 2 Empire State Buildings, and it rotates at a rate of 1 revolution in 2 hours and 15 minutes, so it has a tremendous amount of energy. Plus, it has an asteroid companion. It's a small pebble 520 feet wide. It's like 12 school buses or 10 train cars. Its orbital period, that is, the time it takes the pebble to make a complete circle around the asteroid, is about 11.9 hours. NASA believes that asteroids up to 80 feet wide are likely to burn up completely in our atmosphere due to friction with the air, so they're not hazardous. Asteroids between 80 feet and half a mile in size will not burn completely and could cause severe damage. And asteroids over half a mile have the potential to wipe out large cities or even entire states. In that sense, we can consider Didymos potentially hazardous. So we're going to test one way of defending against asteroids on it: kinetic impact. That's why we sent DART here. So our spacecraft is going to hit an asteroid, only not its main body, but its little companion. DART is already moving toward it at about 4 miles per second. At that speed, a trip from New York to Washington, D.C. would take less than a minute, and a trip across the United States from coast to coast would take about 10 minutes. DART is getting close. 3 seconds to impact. 2, 1, BAM! The spacecraft crashes into the asteroid at full speed. What are your predictions? Asteroid explodes and is blown to pieces? Or asteroid flies off the main body into space like a billiard ball? Well, scientists predict that this collision will reduce the speed of this small asteroid by a fraction of a percent, but it'll still be enough to reduce its orbital period by a few minutes. Then our telescopes on Earth will be able to study the effects of the collision in more detail. And to learn even more, we'll send another spacecraft to Didymos on another mission. This is Hera. It'll be launched in 2024 and is scheduled to arrive at Didymos around 2027. This spacecraft will carry a bunch of research equipment to assess the collision damage done by DART. When it arrives, Hera will take many pictures of the small asteroid, including a fresh impact crater. Hera will also be carrying 2 CubeSats. These are miniature space probes, smaller than a shoebox. It'll launch these mini satellites, and they will make an even closer approach to the asteroid. They will study this space rock for 3 to 6 months. At the end of the mission, one of them will attempt to land on the asteroid's surface to learn even more about its composition and internal structure. It's also possible Hera will carry a mini impactor. This thing will have to make another impact on the asteroid. Then scientists will be able to evaluate the difference in impacts with a large spacecraft and a small one, and understand how we can defend against asteroids in the future. In theory, we don't need to send a giant rocket to a dangerous asteroid to destroy it. A single strike might be enough to shift the trajectory of the asteroid slightly. On a cosmic scale, changing the trajectory, even by a fraction, would dramatically change the asteroid's finish point. But kinetic impact is not the only way to deal with hazardous asteroids. Check out the gravity tractor. For this technique, we need to send a spacecraft toward the asteroid too. Only it won't crash into it. It'll have to go into its orbit. Any asteroid has a force of attraction, and it'll pull the spacecraft toward it. But the spacecraft's engines will keep it at the same altitude, so the asteroid itself will start attracting to the spacecraft. This method is reliable enough, but it takes a long time. And it'll only work if we detect a potentially hazardous asteroid many years before it arrives at Earth. We should have enough time to send a spacecraft to the asteroid and then carry out an asteroid tractor technique. The other option is a laser. When an asteroid is found, we need to aim a powerful laser beam at it. It'll heat up a certain point on the asteroid, causing the material there to evaporate. This is where physics comes into play. The material on the asteroid evaporates upwards. It makes the asteroid itself move downward. Just like our rocket engines work, the burning fuel is ejected one way and the spacecraft moves the other. We can also use solar power instead of lasers. To do that, we need to build a big space station, which would be equipped with a lot of magnifying glasses. Have you ever tried to burn letters on a wooden surface with a magnifying glass? Well, we'd be doing the same thing, but with an asteroid. The space station will have to focus lots of the sun's rays into one point on the asteroid. Again, the material evaporates because of the high temperature, and this causes the asteroid to change its trajectory slightly so that it flies past our planet. How about foil? That's right, we can avoid a collision with an asteroid by using ordinary foil. We would have to wrap the asteroid in the same reflective material. Then the asteroid won't absorb the sun's rays, but will instead reflect them. This creates a little pressure on the surface of the asteroid. It's as if the sun's rays are pushing the asteroid, and it'll be able to change its trajectory. And not the most obvious but reliable option is conventional rocket engines. We can put several powerful engines on the asteroid. This would create thrust and change the trajectory of the asteroid. And if there are enough engines, we can even take control of the asteroid. So when a bigger space rock appears on the horizon, we'll turn on our engines and point the asteroid straight at it. Such a collision can completely destroy even a very large asteroid. And it would make for one epic light show.
For decades now, people have been dreaming of exploring space. And since the year 2000, there has indeed been a continuous presence of people in space. And recently, a new record has been set. Just a couple of weeks ago, there were 17 people from 5 different countries in Earth's orbit at the same time. The previous record was set in September 2021 during the privately funded Inspiration 4 mission. At that time, the number of people in orbit reached 14. So let's see. Just recently, 3 more people have arrived at China's Tiangong space station. There were 3 more astronauts aboard the same station, but they've been there since November 2022 and are supposed to return back to Earth in June. Then there are 7 people on board the International Space Station, and 4 more departed the ISS aboard SpaceX's Crew Dragon named Freedom. They successfully returned to Earth on the 30th of May 2023, leaving 13 people in orbit. Interestingly, the current record also includes the 600th person to get into Earth's orbit. Specialist Rayana Barnai from AX-2 mission became a space traveler number 600, as well as the first Saudi woman in space. But I've got something even more exciting to tell you. Oh my! The record for most people in space, and just not in Earth's orbit, was reset not so long ago too. But it lasted for a mere 5 minutes or so. But during this short period of time, there were 20 people off the planet. This record was set when 6 members of the Virgin Galactic Unity 25 Spaceship Two crew happened to be in space at the same time as 3 Chinese taikonauts living and working aboard Tiangong and 11 astronauts on board the International Space Station. Now that's getting crowded. Well, the International Space Station has always hosted the majority of space travelers from Earth. But I bet there are some cool facts about this marvel of technological development you haven't heard yet. The ISS is the 3rd brightest object in the night sky, and the coolest thing? You can sign up for a special service and you'll get a text every time the ISS travels over your location and is visible with the unaided eye. I've seen it dozens of times myself and it's very, very cool. Normally, you can see it between dusk and dawn, but be ready because the station is very fast. It moves at a speed of 5 miles per second and circles our planet every 90 minutes. The International Space Station is a true record breaker. It's the largest human-made object in space. It's 357 feet long from end to end, which is about the same length as a soccer field. It also weighs about 450 tons. 8 spacecraft can dock at the ISS at the same time. The working and living space of the station is bigger than a 6-bedroom house. Astronauts have 6 sleeping quarters, a gym, 2 bathrooms, and a beautiful 360-degree view from their special bay window. Now to the nitty-gritty. On the ISS, you wouldn't have to deal with lots of disgusting smells. There is a specially trained person who smells everything astronauts take with them in space. It's done to protect them from unpleasant odors. The thing is that you can't really air the room out there if you don't like how it smells inside. That's why NASA is very careful about what kinds of smells are allowed to pass through. You'd also have to get rid of your clothes instead of washing them after each use. To bring a mere 1 pound of load to the International Space Station costs up to $10,000. That's why it's easier to throw your clothes away when they get dirty than to waste water washing them. Now, while sleeping, you'd have exceptionally good airflow around you. Otherwise, the carbon dioxide you'd exhale would form a bubble around your head and you get oxygen deprived, and that's not good. Now, people often think that in space you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the Moon can orbit Earth and the Sun doesn't float away from our home Milky Way galaxy. But astronauts on the ISS experience not full-fledged but microgravity, which means itsy-bitsy gravity. Earth's gravity on the space station is not only around 10 to 12% weaker than the gravity on the planet's surface, but astronauts are constantly in free fall. The spacecraft, the people inside, and all the objects aboard keep falling forward, not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. But our space exploration plans are much more ambitious than just orbiting our planet on board the ISS. We're planning to send a mission to the Moon and build a colony on Mars. Some experts claim that in the next 25 years, around 20,000 people are likely to leave Earth. But how many people would it take to colonize an entire star system? In 2002, anthropologist John Moore from the University of Florida stated that a spaceship with 150 passengers could leave Earth and set off on a several thousand years journey to another star system, and upon arrival, the descendants of the original crew could build settlements in a new world. That seems like a lot of work to me. Let's continue. The nearest star system, Proxima Centauri, is 4.2 light-years away from our home planet. Talking about space, it's just next door. But for us, it's so far that we would need to build a generational spaceship to get us there. But the question is how many people you'd need to send on such a mission to have enough genetic diversity. A new study disagrees with John Moore, claiming it must be way more than 150 people. According to a scientist from Portland State University, a spaceship traveling to such a distant world would have to carry at least 10,000 people. This number might secure the success of the mission. 40,000 people would be even better. Who knows what could happen to the travelers during such a challenging and unprecedented journey? At the moment, NASA isn't ready to send humans even to Mars, let alone a distant solar system. But a few private organizations are working on this project. They hope to make interstellar trips possible in the next century. They count on a huge increase in propulsion speed, which could potentially reduce the travel time between stars to a mere few hundred years. Researchers have built several simulations to figure out how many various scenarios could play out during such an interstellar mission, and they have come to the conclusion that the success of this mission would greatly depend on the size of the starting population. Genetic diversity would keep the travelers healthy. The larger the population is, the more diversity it has. And 150 people is definitely not enough to maintain genetic variations. Even a population of 500 people wouldn't be sufficient enough. At the same time, if we sent to another solar system 40,000 people, we'd be able to maintain 100% of the variation. Even 10,000 travelers would make the scenario relatively stable, which means that any number between 10 and 40,000 people would be a pretty safe bet. But of course, we wouldn't be able to send so many people in space in just one spaceship. We'd have to build many and spread people among them. These ships could be modular, able to dock together for trade and some social gatherings, for the genetic variety, I'm guessing. But they would travel separately, so that if some disaster struck one of them, the rest would remain unharmed. But to make interstellar travel possible, researchers and engineers will have to overcome loads of obstacles. We still need to increase propulsion speed, deal with the negative health effects of living in space, and invent self-sustaining systems providing air, water, and food. Or we could just decide to fix our own planet and stay home.
Have you ever tried riding your bike over nails? I guess it wasn't your intention, but if it happened at least once, you don't want to live through that experience again. Now imagine you'd have to ride your bike on Mars. Its surface is covered with rocks, canyons, volcanoes, dry lake beds, craters, and red dust. That combo makes those nails look totally harmless. No wheels we use down on Earth will do the trick. So NASA has been working on developing the perfect ones for use on the Moon or Mars since the 1960s. They tried smooth rubber tires with inner tubes full of nitrogen, large flexible wire mesh wheels, and airless compliant tires made of several hundred coiled steel wires. The spring tire. But nothing was good enough for the challenging cosmic terrains. The wheels of Mars Curiosity rover only lasted a bit over a year before they got seriously damaged. The rover's tires faced two big problems. First, they had to be strong enough to carry the enormous weight of the vehicle. Engineers tried to make it the most efficient vehicle for exploration, different from previous models that worked on the Moon and on Mars before it. That's how it ended up being so heavy. A big, heavy car needs durable tires, you know. And of course, the surface of Mars is no walk in the park. The engineers tried to make tires out of aluminum, which is a lightweight and strong material, but the wheels got shredded soon. The damage didn't prevent Curiosity from doing its job, but it did affect how efficient it was. And that's where the new, reinvented wheel rolled in. NASA decided to replace aluminum with a material called shape memory alloy. It's made of a unique type of metal called nitinol, a blend of nickel and titanium. Unlike other materials that bend out of shape under pressure or heat, This cool substance reverts back to its original shape on its own in the same circumstances. Nitinol is the hero up on Mars, but it's also useful down on Earth. Just imagine your tires never getting punctured again. Sounds good to me. One company decided to use this tech on their bikes. The tires are tube-shaped and squash down when you roll over a bump. They will develop perfect shape memory over time. They're supposed to work best on gravel, trail, and mountain bikes. The metal surface is covered with a rubbery outer layer. When it wears off eventually, the company plans to retread the tires to make them last for years. The previous airless tire models were made of patented foam that was supposed to last for up to 5,000 miles. They didn't take off because they made the bike too heavy. The new model is supposed to solve that problem. Nitinol also works great in the field of heart surgery. Tubes made of it can expand to the desired width under certain temperatures in the human body. The tire isn't the only object that works better with shape memory. If you can't imagine your sleep without that comfy memory foam mattress, you can send a thank you note to NASA for it. Its history goes back to 1966, when they decided to customize seats for astronauts to somehow ease the effects of G-force on takeoff and landing. Creating a custom seat for every flight seemed way too impractical, so memory foam saved the day. It easily adjusted to astronauts' body shape and went back into a rest state when not in use. In the 1980s, it went from space down to the earthly public. Now it's in mattresses, pillows, amusement park rides, horseback saddles, and football helmet liners. The third-generation memory foam has gel particles and viscofoam inside. That's the secret to its superpower of reducing trapped body heat, springing back up in no time, and making the mattress feel soft as a cloud. The name says it all, but in case you ever had your doubts, space blankets were indeed invented by NASA with space in mind. Back in the 1960s, they were preparing for the space era and looking for a thin, reflective metallic material that would protect their spaceships from solar radiation. And they managed to design just the perfect material MPET, strong enough to be used as insulation to protect expensive space electronics from temperature swings. Ever since, it has been an important part of nearly every mission to and beyond the orbit of our planet. It's also used in spacesuits to protect astronauts from radiation and the sun's heat once they venture into open space. Down on Earth, space blankets are the best friends of marathon runners. Since body temperature drops after they stop running, they need something to help bring it back to normal. And the magical space blanket material can also protect your phone from extreme heat and cold when used as an insulation layer in a phone case. In the early 1960s, headsets for airline pilots used to be really bulky. They often had to use handheld mics to communicate. NASA needed a more reliable and lightweight technology for their missions to make sure the communication would go without any problems. In 1961, the Liberty Bell 7 capsule splashed down, and astronaut Gus Grissom nearly sank without radio transmission or contact with his recovery team. NASA reached out to a manufacturing company to design a headset that could be planted into an astronaut's helmet. Just 11 days later, the team came up with a microphone headset unit that could be used by astronauts to communicate with one another and with Earth. It even had a noise-canceling feature. The headset was later improved and used for Mercury and Apollo missions. The world was able to hear Neil Armstrong's most famous phrase as he landed on the moon thanks to that wireless headset. Freeze-drying tech for food was not created but greatly improved by NASA to pack more snacks on long Apollo missions. During the first human missions, astronauts had to eat bite-sized cubes, freeze-dried powders, and squeeze semi-liquids out of aluminum tubes. Doesn't sound like a festive meal, right? The astronauts weren't happy about this diet, so NASA had to think of a better solution for the Gemini missions. They funded research that ended in developing special gravies that could go into edible shape in hot water in just 5 minutes. The idea of freeze-drying is to cook food, then freeze it under low pressure, and then slowly heat it in a vacuum chamber to remove ice crystals. Thanks to this tech, food maintains 98% of its nutritional value, with only 20% of its original weight. NASA kept improving the tech in the following decades. Now, freeze-dried food is a great help for backpackers, disaster relief programs, and anyone who needs to pack light and still get proper nutrition. The infrared thermometer that lets us check temperature from a distance was developed with the support of NASA as well. It measures thermal radiation emitted by your eardrum, a lot like they measure the temperature of stars and planets. Each device has a lens that focuses light from the object onto a special detector that converts radiation into an electrical signal and then into temperature that you can see on a display. It's used for many purposes, from monitoring hotspot temperatures in mechanical and electrical systems to checking the temperature of visitors in public places. I bet you didn't see this one coming. The technology behind selfies comes from that designed for interplanetary missions cameras. In the 1990s, one of NASA Labs, Jet Propulsion Laboratory, introduced a light mini imaging system that didn't need a lot of energy to take high-quality photos from space. This tech is used in cell phone and computer cameras, and if we go back to the 1960s, we'll find some good evidence that the whole idea of selfies could belong to astronauts. Edwin Buzz Aldrin, the second man to walk on the moon, took some selfies up there with a specially designed Hasselblad camera. He even used the spacecraft as a tripod to stabilize the image and get his face in it. Remember this if you ever end up in space with no one to take photos of you.